Yeah, good afternoon, everyone. Thank you for joining the webinar. Uh, Today, I'm going to introduce about our company introduction, followed up with today's topic webinar. So, we are Powersys, and we are mainly specialized in electrification, and since 2002, and also we are experts in model-based simulation softwares, and we have 50 plus electrical engineers across the globe from North America, Europe, and Asia. Especially, we are focused on EV, and especially what we do. Uh, our technical experts will help you to avoid the gap in the technological update, and this will make the e-motor design robust. Overall, this will eliminate the production phase risk, and hence it will reduce time to market. Yeah, we have a global presence of 8 offices. We are located in India, Bangalore, and we have offices across the globe from US, France, and Detroit, Germany, etc. Yeah, we are on the mission to move e-motor design to one prototype. Our main motto is to reduce the number of hardware prototypes and increase your simulation speed and reduce the simulation time. And this indirectly reduce the time to market and increase your profitability. These are some of our focus markets since 2002. We are providing our solutions to the various industries like aviation charging infrastructure, automotive industries, and various academics from tier 1 tier 2 academics. uh, and also we have a strong partnership with JSOL. They are our main developers of the JMAG software. Since 40 years they are developing the software and providing the best in class solutions in electromagnetic simulation tool. Yeah, these are our some of the focused portfolio in PowerSys. We have a JMAG, and Simba JMAG is mainly for electromagnetic simulation tool, and Simba is for power electronics tool, which uses for battery
Sorry,
power
with
inverters.
cash, right? With cash. With cash.
Yeah, we have also like power computing, which is high accuracy and large scale computation, which is mainly used to increase your speed of the simulation, reduce time to market. Yeah. Our company value proposition is like we are experts in electrical engineers, which deals with electromagnetic, power electronics, and multi-physics simulations. And all the above simulation can be carried out with accuracy. And also, we provide hypercomputing, which provides faster and optimized design outflow. Yeah, these are some of our Indian customers who are regularly using for their development activities. And also we have academics from tier 1 and tier 2. These are some of our global customers, and they are regularly using for their development activities. Thank you. I will pass on to Nitara, and she will be going to continue this webinar. Thank you.
Thank you, Ganesh. Good morning, everyone. Thank you for joining the webinar. Today, myself, Nitara, I'm JMAG HPC engineer from PowerSys. Today, I will be discussing about the topic on the webinar for the design of IPM machine with hairpin winding for electric vehicle applications. So today we will mainly focus on the topic as listed here. First, we will be discussing about the background of hairpin winding. Then we will be seeing overview of JMAG designer analysis. In that, we will be mainly seeing regarding electric motor design loop, machine designing using pre-calculated map, pre-calculated parameter map. Then explanation included introduction for the hairpin winding, application region, detailed coil modeling for the motor using JMAG. Then we will move to the analysis using JMAG software, where we mainly focus it on the skin or proximity losses, efficiency map comparison, and winding material analysis based upon copper versus aluminum. Then we will be seeing some of the case studies. It include case study 1 for the selection of conductor size, then case study 2 that is regarding winding material comparison, that is copper versus aluminum. Then conclusion of the title, then we'll see some of the advantage of the JMAX software. First, let me discuss about the background of the hairpin winding. Here, we can see nowadays or currently or in future, mainly we are focusing on the hairpin winding, how it can be developed, in which scenario it has been started. We will be seeing in this slide. So first, emergence in automotive industry. Here, we can mainly see the hairpin winding has gained a significant prominence in drivetrain motors, where it is used for electric and both as well as hybrid vehicles. The automotive sector has spurred innovations in manufacturing and application of hairpin windings. There are multiple reasons for the adoption in EV traction motors. It includes automotive application demand, compact design, high efficiency, and high speed operation. Battery voltage limitation in EVs imposes constraints on the number of turns in the winding. Also, hairpin windings enables a high slot fill factor, making better use of available stator space. So from this, we can understand hairpin should have some of the advantage that can be in related with this automotive contours that can be seen here, such as it support mainly for high power density due to the copper efficient copper usage. Then it will be enhances the thermal performance as well as mechanical stability. Also, it is better study suited to automated manufacturing it because it is aligned with the mass production needs. So, what will be the industry impact? Mainly, it is the transition to hairpin winding in EV motors represent a shift from conventional winding technologies like random or distributed winding. So, automotive demand has led to innovative developments in insulation, shaping, and joining technique for the hairpin coil. So, about the webinar, here we will be today discussing this webinar explains to find and optimize the solution for a good winding design that can be produced easily in high volumes and keep a good compromise between the cost and performance. So first, I will give a brief overview regarding JMAG software, where software is a platform of FEA tool will be utilized to understand and analysis of the hairpin behavior in the different motor application, mainly PMSM. So this is the main JMAG structure and its application overview. As we can see here, we will call it as a product structure also. We have different part as classified into 4 different parts. The first one, it is regarding solver. In JMAG, we have different solver as mentioned here, such as magnetic, electrostatic, thermal, structural, as well as thermal stress. So it's a one platform we can do multi-physics analysis by accounting all these analysis such as magnetic, thermal, structural, etc. Move on to next point, that is an efficient HPC implementation and optimization. Of course, nowadays not only the analysis electromagnetic or mechanical is not or it's required. Of course, along with that, we mainly need to be do the optimization analysis also. So there is no need of any other part of software to be added with the JMAG to do those analysis. So JMAG will help us to do with the same module to be do parametric as well as optimization analysis. So we know the optimization is a time consumption procedure. To do easily that we can incorporate with the high platform scenarios such as HPC. For that, it will support job schedulers such as LSF, PBS, TOR, Slum, Condor, etc. Move on to the third point, that is a common CAD for FEA. Of course, any of the basic analysis, we need a set of input. In that, mainly we require the CAD. So the CAD of any of the model can be designed in any among this any of the CAD software. So the JMAG software is we can easily configured or connected directly with this CAD software file. So we can directly import those files into the software. Move on to fourth part, that is the integration of different simulation tool. As I mentioned here, like we can do different features, different multiphysics analysis we can do with the software. Along with that, we can connect with the other software easily. So that has mentioned here, JMAG can first part that is shown here, JMAG RT. In JMAG RT, that is a real-time tool where we can directly connect with the SILs, MALs, HALs as shown here, that is like MATLAB, SimLab, all those things, direct connection is available. Then another part that is a direct interface. So the partners products such as Nastran, Abacus, Optimus, these platform can be directly connected with the software. Or in other term, if we want to connect with a third-party system such as Nastran, Abacus, Optimus through the multi-purpose file. So where we can take the result from the JMAX software and can be utilized with the third-party software. So these are the different part of the software where we are looking into today's analysis. So let me quickly discuss about the motor design workflow using JMAG. Here this cycle we will call it as a V cycle, where there are different part of software can be utilized in proper way to get it or to reach from the starting or initial designs on to the end stage, that is a product testing stage. So once we are going through the multiple validation, as per our tagline, we can reduce our prototype as the analysis has been going through these multi stages. How we can means achieve this point can be explained here. So as in JMAG, we have different parts such as JMAG Express Classic, JMAG Express, JMAG Designer, where JMAG Express is an analytical tool where we can do only quick calculation to understand the conceptual analysis. So once we are have an idea or our design is in line with our objective, we can directly move to the JMAG Express. JMAG Express is a part of JMAG Designer, or both we can take one into another one. So here in JMAG Express, we can do the FE analysis as well, but it is a quick tool also. So the basic all type of analysis can be done very quickly by using JMAG Express. As I mentioned, large scale parameter sensitivity analysis also can be do it. And at this stage also, we can do the system level requirement verification to help of JMAG RT. And if you want to do the optimization by including different multiphysics analysis, we can move to JMAG Designer, which is the main part of the tool where we can do the FE analysis, different custom, not only the basic template, we can do different customized analysis can be done in the JMAG Designer. At this stage also, we can do the ML's analysis like by considering system model verification as well as controller designer with the help of JMAG RT. Then JMAG Designer also will support the 3D modeling that can be mainly utilized for the high fidelity component definition as well as component validation. Of course, multiphysics also can be in different scenario. We can be applicable or do the analysis in the JMAG Designer. And from this, we can do efficiency map, control design, everything. Then we will move to HAL, that is a system verification calibration through JMAG RT. Then we will be reaching to our final stage, that is a product verification and testing. As we can see, we are going through multiple stage and we will be doing the different way of analysis and finding this most suitable result that is meeting our requirement. We may not be do the multiple prototype production at the final stage. So this is the way how we are achieving our tagline, minimal prototype, by using the JMAG analysis. Without any time lag, we can move to our main topic that too we have to discuss today. So that is we before entering into the main part of the topic, we'll see what are the different electric motor design loop. So we know electric motor design loop, it's kind of loop, can be consist of different stages. such as cost analysis, winding layout, electromagnetic simulation, thermal simulation, and mechanical simulation. And this path will be continuing as a cycle. Still, we will be achieving, or we can get our means our objective way. So in the first stage, if I am considering as a cost analysis, it consists of different stages. It include detailed bottom-up calculation, including material, manufacturing, and tooling and overhead costs. Of course, it consists of bill of material, cost report, then main cost drivers and economization suggestion. Then we will move to winding layout stage, where we can be find out the customized layout of hairpin windings and adaptation concept of for the machine scaling. Then early assessment of producibility as well. Then once we are run with our initial all design parameter, we will move to the different analysis. In that first basic analysis come into the electromagnetic simulation, where we can mainly do the FEA simulation of, as it is mainly focused on the winding, we can be seen the FEA simulation for the current displacement, then calculation for additional AC losses, of course, do the calibration of the analytical estimation model. Then the next stage that is coming under thermal simulation, where we will be mainly understanding temperature distribution of the model, mainly if we consider the winding part also. Then FEA and lumped circuit thermal calculation. It is a continuous operation and temperature cycle. Of course, we need to do cooling dimensioning as well at this stage. Then move on to the mechanical and simulation stage, where we can coordinate with supplier specification to do the 3D CAD design and assembly instruction, verification of producibility, creepage distance, and mechanical stability, always tolerance requirement also, and its impact. So these are the basic loop what we mainly will be doing for the electric motor design. So here, how machine design can be using a pre-calculated map. In that, mainly we know usual machine design. It start with a predefined geometry with a fixed parameter set. Where there is some problem regarding in that way, if once we will do, we cannot find then global optimum result. Only we will be obtaining the local optimum result. So to get the global optimum, we need a completely different starting geometry. So the solution can be explained in such a way that we can use a pre-calculated parameter map for the thousands of geometry variants. So here we are seeing the stages how we mainly moving forward for the any of the analysis. It includes some of the input parameters such as DC voltage, current limit, peak torque, and peak power. Once we have this set of input, these are the input parameter getting from the customer, then we will start to do the choice of start geometry. Then we will try to optimize those geometry and we will be getting some result. But the way how we can do it, another thing is that pre-calculated parameter maps, where we can use of equivalent circuit parameters such as permanent magnetic flux linkage and direct and quadrature inductance LD and LQ. So this parameter depends upon the rotor structure, magnet and air chamber arrangement. So if we have the more magnet layers, the lower permanent magnet flux and higher reluctance torque will be achieved. So the thing is here need to be explained that the parameter map we can pre-calculated using JMAG that can be used as a database for the specific design problem. So this LDLQ curve will be helping us to understand and finalize with a better result. So now we'll move on to give a introduction regarding hairpin winding. So hairpin winding is a winding where we can see it is in the form of bar, will be pre-manufactured in I or U shape. It have a straight line, will be feed through machine and twisted and widen at the other end. That is the main structure we can see in the figure as well, how the hairpin winding will be look like. Then twisting to the next connection point of the winding. So just I would like to compare the both wire technology or winding technology. One is the hairpin winding technology, another is a rounder winding technology, as I mentioned the pictorial representation also. Where main properties or features of the hairpin winding technology, so it have higher fill factor, reduced DC losses, stronger insulation system, reduced iron losses, and improved space utilization. But for the round wire technology, it has more winding design flexibility, reduced AC losses, and less complex manufacturing. Move on to hairpin winding in detail. So this is how looks like both the winding where we can tell hairpin winding has the higher power density, higher efficiency, higher reliability. Also, it has improved heat dissipation, reduced NVH, as well as automated manufacturing. So we can tell or we can conclude that hairpin winding with preform conductors are the current or next generation solution for the high performance EV traction motors. So this is the thing how I can showcase the comparison of the fill factor, where I have taken both type of winding. One is the classical round wire winding, or it may be either distributed or concentrated winding, and the right side indicating the hairpin winding. So we can see in the same area if I am considering how we can achieve the fill factor for the both the type of winding. So in the left side, our normal round wire winding, we can see if we are keeping how the structure will be created and how we can get in the fill factor. But by seeing the hairpin winding, how we can maximum occupy in our slot space. So from this easily we can understand that hairpin winding provide the highest copper fill factor. Move on to axial space requirement also. We can see hairpin winding structure. There are two side for the winding. One is up and down if we will see. One side we can call it is a welded wire. Another side it is a bend side. So we can see as we have this different feature for the hairpin winding, it can be easily compared with the distributed winding as shown in the right side of the picture. So I can tell easily that hairpin winding provide the smaller end turn height also. Move on to hairpin technology in the industry. There are different way we can be seen in the industry as well. So in industry, we will use it some other name also or nomenclature, that is preformed coil or diamond coil. It is also widespread in industry, and we can usually apply to high power machine, mainly greater than 1 megawatt, and voltage level also greater than 6 kilovolt. We will be seeing the main operating region of the hairpin winding in the further slides as well. So it is a semi-automated manufacturing only will be mainly applicable. Next, it is a manufacturing or welding process. So here, of course, we have seen there are two end of the winding. One is a welded end. So that welding is much important for the hairpin winding. So welding is done one or both side can be do. That is example like IPM winding. So laser welding only mainly preferred for the hairpin winding manufacturing detail. So widening of the head makes small winding heads and keeps space for the connecting, and this connecting can be laid between the layers or spread it across multiple axial planes. These are some features of the happy winding, how it is mainly differentiate from the round wire concept that has been seen in the previous slide. Now we will see about the application region of the hairpin winding. So this is the graph where we can easily understand where are the region. We can easily use the hairpin winding. So the graph is with respect to the continuous power in kilowatt and DC voltage level in volt. So we can see the region and what are the main reason for upper and lower voltage boundaries. The main things are, one is number of copper bars per slot is limited for the hairpin winding. It is about 5 to 8 numbers of copper bar only we will be keeping per slot. And hairpin winding usually form an integer slot winding, that is slot per pole, and it is will be 1 to 2. Then minimum stator slot, which is technologically limited to about 10 mm. So these are the main fees or reasons we can see why the application region of hairpin has been varied at upper and lower voltage boundaries. Now we can see how we can do a detailed coil model for the motors using JMAG software. So the figure or the structure wise in connecting the hairpin winding or making it to in drawing, it is a hectic task by seeing wise. But we have an option easily we can carry it out this procedure in the JMAG. So that I will be explaining here how hairpin modeling in JMAG Designer. In JMAG, it is very easily possible to create a 3D coil geometry, including coil and simply by configuring the parameter settings. So as shown here, we have an option that is calling it as coil template. So coil template functions are mainly used for creating the geometry that include the coil and by specifying just numerical parameters. So here, these are the figures I just put here to understand how easily, how the different way we can be created the coils by using the software. So JMAG coil template features enables the evaluation of losses due to three-dimensional leakage flux and leakage inductance. So winding geometry like hairpin winding for traction motor and winding for large machine can be created by only entering the parameters. So this is not, it can be, as I mentioned here, by just entering the parameter like height, angle, all those things, we can easily create it how many layers, how many numbers should be there in the binding. So it's not a task to draw and do it easily with the help of coil template, we can create in the JMAX software. Move on to analysis using JMAG software. So here we will be seeing some of the analysis study, how can we do in by using JMAG for the hairpin winding. So this is first point where we will see the skin or proximity losses. So we can see the figure, this we will call it as a contour plot, where the figure is mainly representing for the current density. So the value will be showing as a numerical value as well as we can see in the color band. So this color band easily help us to understand how much the value variation happening in each part. So the red color is indicating the most affected area and least value got area can be represented by using the purple color. So like this color band can be easily help us to understand the variation of the values at each point. So with increasing the speed, we can see the current distribution is inhomogeneous and the bar are closer to the air gap are mostly affected. So we can see near to air gap region, all the conductor or pins have the most affected or most value of the current density, or it can be in red color. So additional AC losses to be considered in case of the hairpin winding because high numerical effort otherwise need to be do calculation. Then move on to the efficiency map comparison. Here we have done the comparison for the efficiency map of hairpin winding with the two scenarios. One is without proximity losses, another is with the proximity losses. So of course, if we are adding on losses, our efficiency region and efficiency value will be reduced. That has been observed in the second figure compared to first figure. So in the second figure, as I mentioned, the region where has been most variation compared to the first figure because it have significant higher losses in higher speed region regarding the proximity losses. Also, lower continuous power due to excessive additional losses. Also, it has a limitation of maximum driving speed for battery EV vehicle. Now we will see the some of the influence of design parameter. Here we are considering some example from real BEV motors. So here we are just comparing with a different design. So we can see that for the short pitched winding allow for the best overall behavior compared to slot opening without not worthy effect and objective value. And also we have a flat conductors where low height show bush behavior. So of course we can understand or we know our hairpin have the height reduction as its structure wise and conductor width with only small effect. Best result are reached between 4 to 5 mm. This analysis has been carried out from this graphical representation. Also we can see the benefit analysis. So this has been done in different performance like power versus torque ripple as well as ohmic losses. So we can see low torque ripple requires an approximately 5% reduced performance. Also, ohmic loss is almost independent of the maximum performance that can be visible from the graph as well. Then both low torque ripple and low ohmic loss is simultaneously achievable. Move on to the next topic, that is a reduction of conductor cross-sectional area. So we can different way of hairpin vane structure can be also created to understand how that effect can be get into this. So there is no typical skin effect current distribution with high density at conductor surface. So that's why we can see proximity effect is dominates. So reduction of the cross-sectional area to reduce the eddy current. Other concept than skin effect, typical hollow conductor might be promising. So that's what here we can see another different form. In that one form is hollow conductor, where comparison of the following each from form with the copper or aluminum. So we can see the different structure. One is solid where the reference one. Another one is U form, inner open where 25% of reduced area. The third one, that is a O form or hollow conductor where 25% of reduced area can be achieved. Then solid with the 25% reduced height. Another is U form outer open where 25% of reduced area. So this scenario, we are just comparing with the different winding materials such as copper and aluminum. Here we can see that copper and aluminum, how it can be comparable in similar case in the for the hairpin winding in terms of current density, how much it is getting higher. And here we can easily tell also that 1 by 3 of higher resistivity with the aluminum is also applicable in this scenario. So we can conclude from this figure that increased losses with aluminum we can understand. But what will be the about higher frequency? So that can be seen here how it is affecting with a higher frequency. So this is the conductor variation result, like a different conductor scenario we have already mentioned, like copper solid, copper U form, outer open. Similar way, aluminum solid and aluminum U form outer open can be taken here to compare both finding material with a different frequency. So we can see as a highlighted part where the higher frequency range, so above 600 to 800 hertz, reduction of copper conductor cross section area reduces the resistance. So as we have two type of solid one as well as copper uniform outer open, so which is having reduced cross section that can be used to reduce the phase resistance. Similar way, reducing conductor height is more effective than changing the form. Also, U form is the more effective than hollow conductors or O form, as well as aluminum is more effective in high torque or high current. So these are the main analysis can be understood from this study also. Now we will see some of the case studies where we can compare, or we will see these case studies for the traction motor design using the JMAG. So first case study, here we will be seeing some of slot pole combination analysis. Here we are doing mainly analysis or comparison between two different types. One is for the 48 slot 8 port, another is for the 54 slot and 6 port configuration as shown in the figure. So electromagnetic and mechanical design can be easily combined in the JMAG software. So conductor size analysis in the JMAG software can be done in the first case study. So where we are considering typical operating point can be considered such as peak torque at knee point and peak power operation at peak speed. So these are the two operating condition we are mainly seeing here. And if we would like to select suitable pin or conductor side, which can be feature higher output torque and power, but a reduced winding losses. So this is our main scenario where we want to get it. So we can find it the size, or we have to find out the, or we get it the conductor or pin size for the higher output torque and power, also for the reduced winding losses. So we can see, or the interesting scenario what we can see here, that basically low speed design and high speed design. That is a two different area we have to mainly focus on that. So in terms of selection of pin size, we can see this low speed region as well as high speed region, both are conflicting each other. We'll explain in detail. That means we can see in the low speed operation time, basically most copper loss component in the low speed regions are DC. So we would like to have potentially increased pin size to reduce the DC loss. That means increased conductor height as well as width. So for more copper usage, that will help us to reduce the DC copper loss. That is a scenario what we can take or consider for the low speed region. But in high speed region, we need or when the frequency goes high, AC losses become the prominent one. So which indicate that descent trend to have a relatively reduced conductor height and width. This scenario is exactly opposite to the low speed regime. So the comprehensive design is always to combine both low speed operation and high speed operation to get most suitable conductor size. So that two things we need to consider to finalize the conductor size. That's what initially I have explained. These both scenarios is a conflicting nature. So we will see now the efficiency map analysis for the both scenario or both slot pole combination. So we can see here, we tried both 48 slot 8 pole as well as 50 slot, 54 slot and 6 pole, and we are comparing the efficiency map. We can see that, or we can identify that increasing slot number and winding line number is really beneficial in terms of efficiency. So that can be concluded, or we can understand from this two efficiency map graph as well. Then move on to third figure, that is we are doing done the analysis for the thermal analysis also for these two scenario. One is for the 48 slot 8 pole, another is for 54 slot 6 pole as well. So here in the thermal analysis, mainly to understand the machine temperature distribution under both peak torque and peak speed operation. So we can identify that features to feature high power, high speed operation, we need to increase the slot number as well as layer number. But it will it will be beneficial when to balance the temperature distribution to both low speed and high speed region or operation. So that are the main understanding we can see here. So mainly compared to that, we can tell that based upon the specific performance requirement, 54 slots and 6 pole design show the improved efficiency behavior as well as thermal behavior. Move on to another case study. It is about the winding material. As initially I have discussed, we can mainly go with either copper or aluminum. But nowadays, people or industries are very much interested in thinking about the usage of the aluminum winding, because we know aluminum has some features such as cost effectiveness as well as sustainability. So we want to understand how effectively we can use aluminum instead of copper winding as well. So for that, here the proposed model, that is 54 slot 6 pole with a 10 layer, we compared machine performance with the aluminum winding as well as copper winding. So we can go high layer number as well as high slot number initially, because once we will identify the difference what we need to be taken for the both winding, that is copper winding and aluminum winding, we can further reduce the slot number as well as winding number. So here we see optimization result will shift the direction that aluminum winding will be the more beneficial, because during the reduced slot number and layer number, conductor size will increase. So when the conductor size will increase, AC effect will be more dominant. But we know the aluminum features, it has 60% increased DC resistivity. So in terms of considering AC loss, we know if DC resistivity is increased, it is good for AC losses, but not for DC. Still, we can think aluminum can give us the better performance. So, and for different conductor size option by using copper or aluminum respectively. So here, as I already mentioned, we have identified that based on the 60% of difference in resistivity of the winding material, till aluminum is challenging in machine design, especially in its lead point in peak torque operation. Because at this point, DC loss is quite challenging. So what we need to do is we need to increase the conductor size to reduce the DC loss component. That's what we can see here in this figure as well. We can see here when we are compared or based on the same performance requirement, we have found that optimum conductor size of the aluminum is slightly higher than that of copper. So we can see here with the same performance we are achieving, but the size of the copper is different than aluminum. That means aluminum has increased size. So that is the slight difference in aluminum. Once we are using, we can get the same performance for the both the cases. So because we need to balance the output performance and loss behavior in both low speed as well as high speed region. So this is regarding the case study to different winding materials such as copper as well as aluminum. Now I would like to conclude the topic on today, that is hairpin winding, which provide the benefit to efficiency and manufacturing. It has a trend to high speed machine lead to high frequencies. Also, AC losses need to be minimized to provide good cycle efficiency as well. So JMAG can effectively be used for optimization of slot per bar design. Even slight changes in LD by LQ ratio has big effect on the cycle losses. So pre-calculated inductance map can be used to shorten the design time. Then main advantage of the JMAG, it include, as we mentioned, we have different part. First, JMAG Express, it is a fundamental design parameter we can do easily, such as geometry, material, winding, pattern, all those things. Model creation takes minute and quickly we will be generated the result in seconds. And JMAG Designer, it's have mesh was specifically developed for extremely high quality mesh for the machine analysis. Then we have a very wide and material database. It contains around 800 type of materials directly provided by the material manufacturers. So we can add or customize any other material also in the database. Coil settings, sir, we can easily set up. Already I have shown how easily hairpin winding can be created in JMAG with the help of coil template. Through an automatic coil winding tool that is called as coil template we have, or manually also we can be do. We can also evaluate the actual drive effect by connecting the machine model to a circuit model and perform the analysis by linking the power electronic simulators such as PSIM, MATLAB or Simulink by JMAG RT. So these are the very good features what JMAG has to do, and we can use it in our daily basis analysis scenario. So that's all from my side. Hope you have got an idea about the winding. Thank you. Yeah, I will be going through some of the question. Yeah, thank you for your question. Let me see one by one. Yeah, can a continuous hairpin winding like the one used in lucid motor be done in JML? Maybe that motor winding, how hairpin winding can be done. I'm not sure about the lucid motor, but of course, as I mentioned, the all the variety what mainly in the industry available hairpin winding can be do in the JMAG. As I shown the way how it is done, we can be do it. If in detail, I will see about that and I will get back to you. Thank you for that. Then next question, how complex is to manufacture the motor with the different conductor cross section? Uh, Complex means complexity also regarding that creating in for the analysis I have shown here how it easily can be do in the JMAG software, and we can understand the thing without doing producing as a prototype. You can understand how your performance can be varied, then afterwards you can go ahead for manufacturing about that. Then next question, while calculating the skin effect and prox, does it consider just the frequency of current or it consider the effect of eddy current due to motion as well? Okay. Mainly frequency only, mainly we are considering, but whether eddy current also is considered, I will check and come back to you. Thank you for that. Okay. Okay. Next question in the 54-6 combination, 10 conductor per, but you mentioned there is a limit of max. I have mentioned that limit in the sense it can, that is a mainly practicably used number of conductors, and the other one I have just, it's a study we have considered how much can be that effectiveness can be get it to into that type of design. That type of analysis only has been done in my means PPT, whatever case study I have done it. Next question, below the chart is mentioned that peak power consider is, but in the chart the speed changes. Uh, okay. Uh, okay. Maybe I will check and come back to you. Next question. Yes, which influence has the PWM effect on the losses of hairpin winding? Actually, during efficiency map analysis, we have an option to add externally also. If you have the PWM loss value, we can add on those value also. We can do it. Yeah, can you please demonstrate me? Please connect with us. We can do a one-to-one meeting as well if you want to understand very much details regarding how this will work it. Because as we have time constraint, just the result and main point just I taken how the thing can be do in very short time with a very some values or result I have taken and shown it. So if you are really interested, please connect with us. We will be give you a demo or we can show you in detail how it can be done it. Okay. Next question, can you introduce the insulation evaluation and PDIV evaluation? Sorry, now at moment I could not answer for that. I will check it, and whichever, sorry, I couldn't answer as of now. We will be get in touch with you. We will be sending you in detail all those answers. Sorry for that. AC loss, which methods follow to calculate the AC losses means we have in efficiency map we can create it like different losses and we can get it to into separation of losses. Those possibilities are available in our analysis and we can get the AC losses in that way. Uh, Okay, next question is, could you elaborate more on practical level how the automatic winding tool is working? Are there some limitation regarding to geometry? Yes, yes. We will check on this and we will share it too, because practical ways is we need to check it little more, and I will we will come back to you. Thanks for the question. Um, is there any reference and model examples are available? Kindly provide the same. How practically hands-on session for the designer would be interesting. Of course, thank you for showing your interest on hands-on session. Please connect with us. We will be giving you training and understanding about in detail how we can do it in by using software. Of course, we will be. Please touch with us. The last question, that is how the conflict of different loss composition DC and AC losses in different region can be solved in the context of optimization machine. Yes, it is another interesting point as I told, like a different speed region, that scenario is different, like in the low speed DC loss will be prominent and high speed AC losses will be prominent. Of course, we can be do, and we have some other case studies also regarding optimization, how we can means consider this parameter and be doing as well. Then the last question regarding the optimization of hairpin, which main parameter that need to be conductor height? Yes, that is like optimization. We can be consider lot parameter in our software to do, and that is mainly depending upon your interest. Of course, conductor height also can be taken as a one of the parameter or for the optimization, and different like any other things to be considered, we can take it and we can do the optimization as well. So that are the main way how we can do it for the optimization for the hairpin winding. uh, okay, then the next question, can JMAG simulate partial discharge of the winding in case of winding insulation fault? Yes, we can do that as well. We have different studies also on those things. Please look into our website, or if you want to explain or get it material from us, please connect with us. We will be sharing those thing details to you as well. Yeah. The what about the AC effect in envying? Can you consider the yes, yes, of course. Once we are considering or doing in the 3D, and when this hairpin winding is designing, AC effect also can be considered in the analysis. We doing that as well. So these are the short answer from my side, but in detail we will be sending you in detail the details. And please, whoever are interested to see and understand about more detail about how hairpin winding designing can be do by using JMAG software, please do in touch with us. Then we can be give a more detailed explanation to you. Hope it has been clear your some of the doubt. I can be explain little about all of those doubt. Once again, thank you so much. I think we can close the session. Thank you one and all to join for the webinar. Thank you.